Hello future engineers, subscribers, viewers, and students. Here is another video in dynamics, particularly on kinematics of particles. I hope that through this video, your knowledge in dynamics will increase and you will develop as engineering students in your respective fields. So here are the two problems. This is the first, problem 13. A Scott shock is a mechanism that transforms the circular motion of a crank into the reciprocating motion of a shaft, or vice versa. It has been used in a number of different internal combustion engines and in control valves. In the Scott's yoke shown, the acceleration of point A is defined by the relation A equals negative 1.8 sine kt, where A and T are expressed in meters per second square and seconds respectively, and K is equal to 3 radians per second. Knowing that X is 0 and V is 0.6 meter per second when T is 0, determine the velocity and position of point A when time is 0.5 seconds. So here is the given figure, and take note that acceleration is given equal to negative 1.8 sine of kt, and acceleration is the derivative of velocity with respect to time. So this is the given figure. So dv dt is negative 1.8 sine of 3t. So that means differential of v is equal to negative 1.8 sine of 3t. Integrating, and we divide 3 because if we imagine that 3t is u, the differential of 3t is with respect to t is 3 differential t. So that's why we divide everything we divide the right side by 3. So integral of dv equals negative 1.8 over 3 integral of sine 3t times 3 differential t. So this is the right side. The integral is in the form sine of u differential of u, and the integral of sine u is negative cosine of u, so negative cosine of 3t. So integral of dv is v, so we have negative 0.6 times negative cosine 3t, so that would be positive 0.6 cosine 3t plus constant of integration c sub 1. So v equals negative 0.6 times negative cosine 3t plus c sub 1, and this is positive, so v equals 0.6 cosine of 3t plus c sub 1. Let us evaluate c sub 1 by applying the initial condition that when time is 0, velocity is 0.6. So 0.6 equals 0.6 cosine of 3 times 0 plus c sub 1. Cosine of 0 is 1. So this is 0.6. 0.6 minus 0.6 is 0. So c sub 1 is 0. Therefore, the expression for velocity is simply 0.6 cosine of 3t. And we evaluate the value of velocity when time is 0.5. So v sub 0.5 equals 0.6 cosine of 3 times 0.5, or cosine of 1.5 radians. So setting your calculator in the radian mode, we can compute now the velocity at t equals 0.5 seconds. It is 0.04244 meter per second. Then for the position, velocity is dx dt, so 0.6 cosine of 3t, and dx dt is 0.6 cosine 3t. So that's why dx is 0.6 cosine of 3t times differential of t. So integrating both sides, and before we integrate the right side, we divide by 3 again, so that the right side would be integral of cosine u du. So integral of dx equals 0.6 over 3 integral of cosine 3t dt. And the integral of cosine u du is sine u. So the right side is equal to 0.2 sine of 3t, then plus c sub 2. So x equals 0.2 sine of 3t plus c sub 2. Then let's evaluate c sub 2 when time is 0, x is 0 also. So sine of 0 is 0. So c sub 2 is 0. So after knowing that c sub 2 is 0, x is 0.2 sine of 3t. Then we can now evaluate the position when time is 0.5. X sub 0.5 is equal to 0.2 times sine of 3 times 0.5. Sine of 0.2 times sine of 1.5. So using your calculator, x sub 0.5 equals 0.1995 meter. So problem 14. For the Scotch-Yoke mechanism shown, the acceleration of point A is defined by the relation A is negative 1.08 sine kt minus 1.44 cosine kt, where A and T are expressed in meters per second square and seconds respectively, and K is 3 radians per second. Knowing that X is 0.16 meter and V is 0.36 meter when T is 0, determine the velocity and position of point A when T is 0.5 second. So here is the given figure, and acceleration, substituting k is 3, is negative 1.08 sine 3t minus 1.34 cosine 3t. So acceleration, which is dv dt, is equal to, you just copy. So that means differential v is equal to quantity negative 1.08 sine 3t minus 1.44 cosine of 3t times dt. Integrating integral of dv. So with our experience, we divide the terms in the right side by 3. So integral of dv is negative 1.08 over 3 integral of sine 3t differential times 3 differential t minus 1.44 over 3 integral of cosine 3t times 3 differential of t. So the integral of sine 3t is negative cosine 3t. So negative times negative 0.36. So this becomes positive 0.36 cosine 3t. So v equals 0.36 cosine 3t. Then integral of cosine 3t times 3 dt is sine 3t. So minus 0.48 sine of 3t plus c sub 1. Evaluating c sub 1 by substituting this initial condition when time is 0, x v is 0.36. So 0.36 equals 0.36 cosine of 3 times 0 minus 0.48 sine of 3 times 0 plus c sub 1. Then sine of 0 is 0, so this term is 0. While cosine of 0 is 1, so this term is 0.36. 0.36 minus 0.36, so c sub 1 is 0. So therefore, velocity is 0.36 cosine 3t minus 0.48 sine 3t. We then substitute 0.5 for t to evaluate the velocity when time is 0.5 seconds. So v sub 0.5 is 0.36 cosine of 3 times 0.5 minus 0.48 sine of 3 times 0.5. Setting your calculator in the radian mode, then let's evaluate this expression. Velocity when time is 0.5 seconds is equal to 0.4533 meter per second. So next is velocity, which is derivative of x with respect to time, is equal to 0.36 cosine of 3t minus 0.48 sine of 3t. So that means dx is quantity 0.36 cosine 3t minus 0.48 sine 3t times differential of t. So again, integral of dx is 0.36 divided by 3 integral of cosine 3t times 3 differential t minus 0.48 over 3 integral of sine 3t times 3 differential of t. Integral of cosine is negative sine. Integral of cosine is positive sine, rather. So this is 0.12 sine 3t, while integral of sine is negative cosine. So this is negative cosine times negative 0.16, so positive 0.16. So x equals 0.12 sine of 3t plus 0.16 cosine of 3t plus c sub 2. So evaluating c sub 2 when time is 0, x is 0.16, so 0.16 equals 0.12 sine of 3 times 0 plus 0.16 cosine of 3 times 0 plus c sub 2. So again, sine of 3 times 0, sine 0 is 0. First term is 0 in the right side, and cosine of 0 is 1. So the second term in the right side is 0.16. 0.16 minus 0.16 is c sub 2. So c sub 2 is also 0. So x therefore is 0.12 sine of 3t plus 0.16 cosine of 3t. Then, using your calculator, let's evaluate the position when time is 0.5 seconds. So x sub 0.5 is 0.12 sine of 3 times 0.5 plus 0.16 cosine of 3 times 0.5. With your calculator still in the radian mode, the position of of point A is equal to 0.1310 meter. So that's it for this video. I hope that you were able to follow the explanations and the solutions.